video production strategies with image sequences, and the speaker is Thomas Winningham. He's a first-time speaker here with us.
All right, thank you very much. All right, so hi, my name is Thomas. This is a little bit about some experiments I did with Python and how to do sort of video production and whatnot using a very minimalist approach to such things. So hopefully you'll be able to get some kind of useful information out of this. And I think you'll see that Python is really great for this kind of thing. Kind of puts you in a good position in general with video production and being agile to, produce just about any kind of, video production that you might want to do. Or at least figure out a way to get it done by using other systems. Python is great at integrating. So I guess I'll go ahead and start here. So video, this is from Wikipedia. Video is a technology of electronically capturing, recording, processing, storing, transmitting, and reconstructing a sequence of still images representing scenes in motion. And that's pretty much your requirement right there. So I guess in our last talk we saw the keynote presenter. He was talking about struggling with making Python on the bare metal, hardware without an operating system. And he was struggling how to do things. Does he want to take Python and just take out the parts that aren't working without an operating system, or does he start with nothing and just add on the little bits of Python that he needs? I would say that most of my experiments have been sort of starting with nothing and sort of adding on to that. And so this is our basic requirement here, that we just need to construct a sequence of still images representing scenes in motion. So image sequences are just that. They're just a whole bunch of images. They can have various formats. Usually when you're doing video or some kind of motion, you need to have them numbered. And often you want a uniform resolution, although different scenes may have different resolutions. Sometimes with video you can switch resolutions, but often that kind of confounds the situation. So often you want to get things into a uniform resolution, either by cropping or adding bars and whatnot. So what are video files, though? There are actually a lot of things. Calling something a video file is maybe something of a misnomer in today's age, maybe more like a media file or just not only audio. There's actually quite a lot of things that are in media files, and quite a lot of things that could be contained in them. In fact, mostly when we think of a video file, we're not actually getting just a video file. We're actually getting a container of various streams. And this can be video, audio, multiple combinations of video and audio, alternate languages. There can be subtitles, there can be alternate text, there can just be all kinds of things. And there's a long history of various things that have been put into video files, including a lot of metadata about the author of the media and other notes. And then they're ultimately played somehow, and whether or not the player supports the various things that are in a video file kind of depends on what kind of features are in the thing and what the player does actually support. For the most part, usually things have a video stream, some audio, maybe subtitles. Sometimes subtitles are in a separate file. Sometimes there's alternate audio, or there's a surround sound and a stereo track, and that's most of the video files out there. Sometimes they're just the video image sequence. So this, I guess in this talk I'll be mostly talking about just video, although there's a lot of other things that can happen in a video file. So there's a lot of sources of video: film, camera, people playing games. Screen captures of systems doing 3D rendering, other creative coding software, or any combination thereof of those sorts of things. There's also a lot of bad things that happen in video. Things like digital rights management, which I won't really talk about, let's just hope it goes away. And then there's proprietary battle lines, like for instance, QuickTime movie format works great on a Mac, but certain versions and certain combinations of things might not work so well on other systems, or you have to get a lot of proprietary software that claims to solve the problem. Maybe it does, maybe it doesn't. There can also be just a lot of bugs in video. Maybe this one program that created a video file, you know, had a certain kind of a opinion of how to do things, and another, or the thing that wound up playing it had a different opinion of how things should go. And there's a lot of performance problems too. Things like, oh, you know, are we getting the data out of the stream quick enough? Video has a lot of things like, say, keyframes and other sync points and stuff with the audio. You know, does the audio get out of sync? Those kinds of things. So there's a lot of crazy things going on with video. Sometimes, if you really dig into it, it's kind of amazing that any of it works. There's also just a lot of opinions out there, and the more you dig into it, the more opinions you'll find, and it can sometimes be hard to get a good video file. But we're going to try to ignore some of that, because we're going to start at a very minimalistic place. Hopefully, whatever problems you may have, the solutions will be in reach, depending on the problems that you might face. So traditionally, we use nonlinear video editors. These are just awesome. These are things like iMovie. What's the Microsoft Movie Maker? I can't remember. I think there's a new name for the Microsoft one. Things like QuickTime. Of course, iMovie on the iPad, or let's see, I think there's a Movie Studio thing now on the Android. And this is basically the traditional way of editing with a video. You have a timeline. You can drag around sequence of clips. You can kind of jog back and forth. It's a very interactive, hands-on approach to dealing with media and video. There's a great one that's on Linux. It's getting better, OpenShot. It seemed like there's one written in Python. I thought it was OpenShot. Also very prominent on Linux is Cinepaint, which is used quite a bit by Hollywood. It actually is maybe a little more closer to what I'm talking about, which is kind of dealing with large collections of just images. So what do you get with image sequences? Again, we're talking about basically just a large folder of JPEGs, or a large folder of RAW files, or some other image format. You basically get everything and anything, because it's sort of the integration point for video between various systems. And this is really how a lot of pros actually deal with video. I'm kind of vaguely remembering some of the DVD extras of Oh Brother, Where Art Thou, where they wanted to give that movie a real kind of 1920s Dust Bowl look. And they actually went through, frame by frame, digitally processing each of those images, you know, to achieve that kind of effect. So quite often in major motion pictures and a lot of professional video, at some point they might deal with just a large collection of the individual frames. Of course, any kind of 3D rendering, Pixar has a product that they developed in-house. I think it's called RenderMan, and that's like a lot of what they use to make their animated videos and stuff, and the output of that is usually a still frame, probably in a very large, let's see, dynamic range format or something that they can then eventually do color correction, and a lot of other, you know, other processes are tacked upon that. But basically, the idea is that you just have a bunch of images. You get anything you can bring to the table, you can do with just a big collection of images. Like I say, it integrates with all systems, and it's something that the pros use. So what is an image, at least in a video? This is pretty simple. It's just like a picture on a camera. There's dimensions, or frame, or resolution, or just the size of it. Resolution, of course, is the interplay between the actual size of the media and the apparent, you know, size of the display. So you'll see those things kind of used interchangeably between systems. It's a little different, say, than film or print or something like that. Most computer monitors are, you know, 90 pixels per inch. And that's kind of changing, though, with higher density displays and whatnot. But that's a little bit more detail. So there's other things, though. There's color depth. I think nowadays everything's at least like 16-bit or 24-bit, or I think some things even do 32-bit, and there can be transparency. There's a lot of things with images going on. Some of the other stuff is the dynamic range formats, things that are beyond the dynamic range of most displays. And so it's almost kind of like a virtual image format where you can kind of adjust the exposure or compress the exposure sometime after the actual image is captured. And that's sort of like your high dynamic range photography and stuff like that you find in the iPhone or some of the other software products that allow you to do that. Of course, you have different image formats. Some of those have compression. Generally, a single frame is going to be static. However, in the context of video, if you're exporting these images, sometimes you might just have a diff, or you may have a full frame, depending on what's going on. For the most part, if you have a video and then you try to get an image sequence out of it, everything's going to be the full frame. So with many frames, though, there's a rate at which they go. Most film video is somewhere in the neighborhood of 25 point something frames per second, or a lot of digital video is 30 frames a second. Some of your Blu-ray and stuff is getting up into the 60 frames a second. Actually, your computer monitor has a 60 hertz refresh rate. There's even higher refresh rates now, 120, 240, depending on how much money you spend. And of course, a frame rate also could be, for instance, in high-speed photography, things like 1,000 to 2,000 frames a second or more. Excuse me. Sorry, I coughed right into the mic. But being down here at this image sequence level is really a great place to be, because you can kind of go with the flow of these things, because we're always going to have the basic concept of film being like the early Edison days of just a bunch of pictures in rapid succession. So also with many frames, like I said, you had compression. It's where you take a keyframe, and then for a little while, so long as the scene doesn't change, you are really only trying to encode the motion differences or other changes to the scene. There's a lot of strategies and opinions for this, mostly things like MPEG-4 will do this. There's also some people in the art world that just take the diffs and drop the keyframes, and that can be a very interesting effect. So what do you do once you have a bunch of images? Is that eventually you do have to kind of put them into a stream or mix it with audio or other video. I've used FFmpeg a lot on the command line. There's also a VideoLAN client and MPlayer. Also, a lot of nonlinear video editors, you can just pull in a whole folder and it will ask you like the frame rate, or you can set the frame rate, and it'll take all of those images and put it right there on the timeline. There's a lot of other things, Handbrake. Of course, in any kind of pro video thing, I would say that your problem and the kinds of tools and the money you'll be spending on them will kind of grow in proportion to the extent and size of the project. So you may find there's a lot of other things, specialty devices and broadcast engineering, to really get really good pictures with even color and all kinds of other optimizations. But for the most part here at home with a weekend project, you're looking at FFmpeg or VLC or maybe QuickTime or iMovie or some of these other tools that you may just have on hand. So where's Python in all of this? I think Python is really great because just in general, it makes the impossible possible. It's very good at expressing intent. If you can just imagine, okay, I have this video and I have this sequence of images and I want to kind of do this thing with it, you can usually begin working immediately in Python trying to express those kinds of concepts, or at least you there with the prompt, you can at least make a first step towards it. Python allows you to do all kinds of things. The standard library is really great. And in general, it's a really great systems integration language. Connects to a lot of things, runs on a lot of systems, has a really great standard library. And yeah, so I think Python, at least for me, has been really great as far as producing video. Here's some things you can do with Python, though. Things like logistic operations. So you have a whole bunch of files. You might, depending on how your computer performs or how old it is, opening up a folder with some 30,000 images or something, and it might not finish on time, or take a good 10, 20 seconds or something to finally render on the screen, depending what's going on. So with Python, you can do a lot of batch file operations, things like renumbering the image sequence, or just moving the things, or rearranging them in whatever pattern. If you can make a for loop out of it in Python, then you can express that for loop as far as taking file actions: copy, move, rename. Rename's really great with like string patterns to pull out some part of the name and put a different part of the name in it. Counting the files, maybe the file numbers are just completely out of whack, but they have the proper date on them, date and time. Well, I guess it'd have to be down in the millisecond, but which you might not be able to get. But you could do things like renumbering. You can also kind of shell out to other programs. There's a lot of great image manipulation tools. Image Magic is kind of set up actually kind of for batch operations on its own. But if there's something that you want to do like every other frame, or something that might be hard to express with an Image Magic shell script, then you can shell out with Python. Of course, Python has the imaging library. That's subject of a talk, I think that's tomorrow, which would be really great to look at. And that's a whole graphics manipulation framework in its own right. And of course, any other tricks that you can bring to the table logistically. You can also do a lot of things with just creative content, actually creating frames of video within Python. I personally use PySVG, which is of course a vector format, and then I used Image Magic to convert it to JPEG, which we'll see here in a little bit. PyCairo, which is a 2D graphics framework. It's actually a system level shared library, the Cairo imaging library, and of course the Python imaging library. NumPy is an interesting thing, working with the Kinect 3D camera. It's very interesting to think of an image as really just a grid of numbers, right? You got a 320 by 240 image, then each of those pixels is just 3 to 4 numbers in its own right. So it's a matrix within a matrix. And so NumPy is a great way with dealing with raw video and a very fast, large scale kind of thing. Everything happens at the system level. So NumPy is really great for that. 3D composition. I had a lot of success with Piglet. I think, trying to think, some of the other talks are going to have other systems. Trying to think, Pygame, what's the other one? Pandas, 2D, and some of those other things. Anyway, I did look briefly into Blender. There are a lot of libraries for actually doing, describing 3D scenes and whatnot. And, but actually most of the Python in Blender seems to be around sort of logistical things like, rendering out movies and kind of, not so much as far as like creating a scene necessarily. But there are other tools that allow you to create things that Blender can import. And then, of course, Python, like I say, is great for integration. I guess the joke is, Python, if it was a significant other, it loves you very much and wants to see you happy and doesn't care if you're seeing other languages on the side. So that would include, I've had a lot of fun with processing, open frameworks, VVVV, and there's quite a wealth of free and open creative tools. Some of processing, I think, was even made a brief appearance in parts of the latest Tron movie. So ultimately, these things also produce an image sequence, or can produce an image sequence. And so it fits in with your entire workflow. It also allows you to take things from one of these things and put them into the other, if you start thinking about things as far as image sequences. So you can also probably imagine all kinds of other things. Any kind of crazy effects. A lot of these things are actually primitive operations, sort of basic operations that in an abstract way could be done in just about any software. There might be some element of reinventing the wheel. I'm not trying to say you devote your entire life to only dealing with image sequences. If you know of a product or know of a way of getting something done and it's in a Nonlinear video editor, there's no reason not to use any other tools. So, some examples. Last night I dreamed up a real basic example. I'll show you here the Pi SVG. And also, it's not a part of the distribution of Pi SVG, but there is a little turtle graphics example that he has in his code base on the Google Code site. So turtle graphics would be like Logo, which is some of my first graphic languages that I learned as a very young child. What we're going to do is we're going to first see what that looks like, and then we're going to try and sequence the actions of the turtle. Show you real quick how I used Image Magic to turn the SVG files into JPEGs, and then kind of show you the command that I used with FFmpeg to mix it down to WebM so that I could show it in this presentation. Here's the output of this program. Let me see if I can switch over here to the code base here real quick. We have, I had to modify this slightly so that it worked independently of the fact that I installed the distribution version of Pi SVG. And basically, this starts to create a scalable vector graphics file. It sets the dimensions. And then we have this arbitrary command language, which is described down here below. And we create a turtle, and we move the turtle to a start point. And we say that we put our pen down, and we give it sort of a direction and a distance to go. And then this thing starts to parse this command line language here, or this series of commands. If the command is F, move forward. If it's a plus, turn right. If it's a minus, turn left. And then finally, at the end of all that, it writes out an SVG file, and that is what we get here, just sort of this basic sort of series of squares. So what does that look like, though, then? So I modified this script just a little bit. At the very first thing here, we start with a frame number. I just add it right to the top here. We're going to start at frame 0. Next, we're going to come up with this simple function here to create a file number that we can tack on to the end of our files for each of the frames that we want to create. So this is just a function. It just puts as many number of zeros at the beginning of a string so that there's always a 4-digit thing. Most of the mixdown software expects images to have a trailing series of numbers, and usually they're padded so that all the file names are the same size. Most of the rest of everything is kind of mostly unmodified. Instead of actually putting the command, the instructions for the turtle to move in the function, I've made it a parameter of the function. I'm also going to make sure that I am modifying the frame number as we go along. But then for the most part, that function, I believe, is unmodified until we get to the end here. So we put our file in a subfolder. We make sure that we pad our frame number to the end of what's going to be called frame, and then going to have a series of numbers wherever our frame number happens to be as we call this function. And down here in the main of the thing, it used to just call it. Now I take just the turtle commands from earlier, make a for loop, and for every command, go ahead and actually draw this from the beginning. So the selector there of the listing of the commands should always do everything and let this command grow over time. So let's see, so in our output folder here from the original thing, we had the SVG file, which has all of the coordinates that were generated. It's basically a single line. We could have just, directly written this file. It's simple enough. Just have a header just start listing out all these points as a part of this parameter of points of this simple XML stanza. Then I used image magic. Basically, the command is convert the SVG file to the output with the file name. And what did I do wrong here? Oh, I've got an older version of Inkscape on this computer than the computer I was using to generate these files. But anyway, you just basically convert it. So that's what a single frame would look like. Here is the video that we produced with the script. And you see there's a basic stop animation sort of sequence. There's also an interesting thing in the sense that with HTML5, I can't rewind this per se while I'm here, and I'm having to refresh. Also, because doing this so literally, we're missing our last frame. You're going to find that there's a lot of these kinds of things in the video world. You'll kind of go down the rabbit hole. There'll be a lot of things such as, off by one errors and encoding weirdness, and maybe I needed to add and duplicate the last frame such that it could make that into a keyframe or some other things. I didn't go into any of that with this. I just wanted to leave it, let you know that there are some caveats to this stuff, and you may have to, towards the end, kind of do some weird things that you wish you didn't have to do or something, but they do make sense once you finally research them all. So that's a basic example. We took a program that was creating a scalable vector graphics. We rasterized it. Then we sort of took it apart to sort of illustrate the sequence of these actions of the logo-like turtle graphics. And we've rendered a video to put on the web. So I wanted to also demo some other things I've done. Probably my first foray into even attempting this kind of thing, a project called La Vie comme l'autobus. My French is horrible. Don't know why I called it something in French when I can't pronounce it. Basically, the local bus system, for a brief time, they aren't right now, I think they're upgrading their system. They put an XML file out on the web that had the GPS coordinates of the buses in town. Many municipalities have kind of an open data of bus tracking. You can track the public transportation. So basically, I had several Python scripts. One script was just downloading this every couple of minutes. Their system only updated like every 2 minutes, so I just made sure like every minute and a half or so I was trying to check it and try to get a copy of just the XML file, the raw XML file. Then I went back through and wrote a script that parsed the XML and just made a basic scatter plot with PyCairo and directly wrote out JPEG images, and then finally reassembled it with just an ffmpeg command once I had the thing. Now I also did some titling in Inkscape and used Python to just sort of copy blank files or titled files so that I could pad out this sort of sequence of images. But basically, and this is kind of hard to see, this is a rendering of the an entire day of the bus system. And I thought I had zoom, but I do not. Anyway, once this flips around, I set the frame rate, I think, at just 30 frames a second, maybe 60, I can't remember right off. But this file is 30 frames a second. It's also a lower resolution. But we're basically just plotting each of the points that the buses take throughout the day. So this is, one per minute, one per 2 minutes. This will flip over to black and kind of reverse color, and it might be a little bit easier to see the pattern here. A lot of this is available online. But it does kind of slowly draw a map of city. There's a nice bright dot towards the center, and that's downtown. The bus system in town is kind of a spoke and hub kind of system. So everything's coming from the suburbs or near the suburbs into the downtown and then back out. Also towards the end, if you have the high resolution one, you can start to see them kind of go around the highway back to the bus garage. So that was my first project that I did with this sort of thing of just trying to think minimalistic, having some data, using these basic kind of drawing tools and creative coding, and outputting that. And so yeah, and I've continued to at least keep this in mind. Now granted, I've done a lot of video with just regular tools or whatever, but I have kept this process in mind. Here's another a little bit more ambitious project. There's a local message board in town called Columbus Underground. I don't think you should really be doing this kind of thing anymore, but basically I downloaded a year's worth of threads from the forum. Again, this was just kind of a hobby project. I wasn't trying to muddy his brand or anything like that. I took the Google Reader cache of the RSS feed from that site, which was kind of XML. And I used another program to actually render a frame for every thread on the forum. So there were 10,000 roughly threads that were started, you know, not posts, but actual entire threads of the message board. And I took, for each thread, did some stats with processing, made tree maps and some other things. And since this took upwards of maybe 2 seconds to render an image, and I had 10,000 of these to go through, it was going to take a couple of hours. So I created a script that allowed me to start up 30 or 40 machines at Amazon's EC2 cloud and uploaded the Java and had each of those render a subsection of this data into JPEGs and then just downloaded them. There's a URL here for the GIS where you can find the source code of that. It basically was a Paramiko SSH script with Python that just logged into all the machines and gave me a single command line for all of them. So any command I typed, it would just, you know, repeat that for 30 to 40 machines. So that was a little weird, and I was kind of hoping that one of them wouldn't screw up and I'd have one machine out of sync with the others, but it's kind of scary moving around files and stuff, but it mostly worked. So the process was upload the data, run the command to render the JVMs, and then download all the images. It was so fast, the first time I ran it, I thought it didn't work, and so I ran it again, and it was, you know, within something like 10 seconds versus several hours. So if something is embarrassingly parallel like this, I highly recommend. I think I spent all of maybe $5 because I only had the machines up for maybe about a half hour or something like that. So it was a very, you know, get it going and then go kind of thing. And then for Mixdown, I used OpenShot. And here's the output of that. So every frame of this video at full resolution is listing a title of a thread that was started for the year. And then as this progresses, there will be other sort of stats. These are dots that represent each of these top 20 people's participation in each of these threads. So if someone talked a lot in a thread, there will be a larger dot as that thread is listed down below. Also composited some other kind of random videos from around town onto this thing. I only rendered a little bit of this for this presentation. The tree map stuff is later. It's really interesting to see the tree maps sort of expand and contract, you know, with the popularity of a thread. So that was another project, sort of assisted with Python. Another sort of maybe ambitious, but much more doable on just a single machine was the using a Commodore 64 emulator and wanting to capture that at full frame rate on a single machine. And capturing video of a running machine, there's a lot of opinions about this. Probably the professional way to do it would be to have like a scan converter that's taking your digital output, a professional, you know, large format scan converter, and then, you know, creates video out of that. But some of the gaming people and stuff can do video capturing at full frame rate using the 3D hardware of modern graphics. So things like GLC, I think there's also something on Windows. There's also some Macintosh programs that are pretty good. But I created a separate X server to sort of get the resolution I wanted and to also load up Compiz and some of these other sort of 3D compositing things, and then running GLC. So there was some scripts to kind of start up this other X server and then switch over to the other X server. So there was a lot of muddiness at the beginning and end of the files and some glitches. It was also at 60 frames a second, whereas I wanted 30 frames a second. So I used the GLC program to record everything. And then it has some utilities to create an image sequence. Python was used to then kind of resample it, take out the, every other frame so that it's, only 30 frames per second instead of 60. And then also just some editing, which was basically write down the frame number where I start, write down the frame number where I ended, and then just renumber everything from that point, to 0 to the end and delete everything else. So here's the output of that. It's a pretty full frame rate. This is a neat little Commodore 64 one-liner that kind of starts generating a kind of a maze pattern, something I saw at the I/O conference a couple of years ago. I think there's a book coming out soon about these kinds of computational one-liner sort of things. But you can see we have mostly, the full rendering of the Commodore emulator. There's some glitches here and there. That may be just artifacts of the emulation process, which is not a perfect, pixel-perfect rendering, but is something of an approximation of the Commodore. So those were my examples. There's some other ideas, or some ideas that I've had in mind, and that is After Effects. After Effects is a great kind of post-production kind of software. If you're doing something with graphics and effects, for kind of the prosumer market or something, After Effects will be kind of your tool of choice there. What's really great, though, about After Effects is that there's a lot of great YouTube videos out there of people using After Effects to come up with interesting effects and other great kind of uses of After Effects to do things, make 3D scenes and stuff like that. There's also Cinepaint 4D and some other stuff. But those kinds of techniques, I mean, usually as they're going through and showing you how to apply these techniques, they're basically being straightforward about what's going on and how we're manipulating the video. Of course, they're interacting with a specialized, customized interface that does all these things. But there's no reason why you can't do a lot of those things with the tools that Python and some of these other image processing libraries give you. So I've looked at some of those things. There's a lot of compositing type stuff out there, with After Effects. So you can do compositing with ImageMagick, things like blue screen, and also with the Python imaging libraries. Just if the color is blue for this pixel, replace the pixel of this other image with that, corresponding pixel. I saw a great video about interlacing, like taking a perfectly good progressive scan video and actually forcing it into kind of really nasty VHS quality interlacing. And his basic technique was you make 2 copies of the film, you advance 1 copy by 1 frame, and then you just literally get every other line from those 2 sets of the images. And then you render a new video with just every other line kind of interlaced. You're actually physically doing the process that the original kind of video processors were doing, just interlacing the frames, much like the guns on the old televisions used to do. A static image looks great, and then as motion happens, you start to see these nice little blurry kind of interlaced lines around the edges of things. But there's no reason you couldn't do that with some shell scripts real quick. Some concepts for live video. This is a very tough thing. Computers are meant to be correct, not really on time. There's a lot of compromises that may have to be made with live video. This might be more the realm of either game programming, maybe things like GStreamer, or just some other creative coding type things, although there is a lot you can do with OpenGL. But loading up a live video stream and then rendering it in OpenGL, there's a lot of inputs and outputs. I just haven't done much with it recently at all, but it's definitely doable to kind of start thinking about live video. So that's it. Thanks. Are there any questions or anything, or does anybody have anything on their mind about this? I think we have just a couple of minutes, right? Or... Yeah, I did briefly mess. So the question was, have I messed with some of the FFmpeg libraries with Python? I did briefly. I did wind up just kind of shelling out to the command line. I think there was just recently some really great command line libraries, shelling out sub-processes and stuff like that with Python. I think my problem was there was always some stupid reason why I was using like a built from source, custom build of FFmpeg. And so I was just happy to get that working, let alone get the other library, or maybe there was some kind of mismatch and weird bugs. So I would wind up shell out. But there are a lot of other great libraries. I mean, there's a whole GStreamer library. Those things are very doable. Oh, they're just wrapping up over there too. So, yeah. I'm sorry? Okay. So any other questions or any other ideas? Have any of you guys messed with any of this kind of stuff at all? Or do you think you will? Yeah. Sure. Sure, sure. Yeah, so Pavre to render Lego, and then using FFmpeg to sort of composite the scene together. I mean, I got my start kind of with Pavre back in the day. It was really great to, have this really junky machine with really bad graphics suddenly produce these stunning photorealistic kinds of things. It took forever. But that's why, now we can, use the cloud, as it were. But yeah, no. I guess that's kind of, how I was inspired by some of this is I wanted to be kind of hands-on and direct, and I knew what I wanted, and I didn't necessarily want to, load up some other large tool when I could already express that in Python or something like that. So yeah, totally right there with you. Anything else, or any other ideas? Or all right, well, thank you guys so very much for coming by. Hope you enjoyed it. Feel free to contact me if there's anything I can do, or if you guys get yourself into some kind of crazy project and need some help, just let me know. I guess that's it. Thanks, and enjoy the rest of the conference. There'll be a lot of other talks that relate to some of these things and maybe give you some ideas how to use these kind of techniques. So thank you so very much.